Okay, class, we're about to start section 7.8, modeling with quadratic functions. Example 1, let f of t be the number of deaths of motorcyclists in accidents in thousands in the U.S. at t years since 1980. Now, first of all, these years, we know that we would do L1. Okay, this is going to jump a little bit, but we know that this is 5, 10, 15, and so on. Let me see if I can write this over here. No, this is going to jump. So we know that this will give us 5, 10, 15, 20, 22, 24, 26, and 28. Those are the values that you will put in your calculator. That'll be your L1. This will be your L2. Now, we have this graph here, which if you notice, it almost looks like a parabola. So we know that this is actually a quadratic formula. It says, consider a scattergram on the data. Is it better to use linear, exponential, or quadratic function to model these data? So we know it's a quadratic function. So we'll put quadratic. And that is because the points go up. Well, actually, they go down first. Points go down, then up. And it has a U shape. Okay, now we go to B. It says, find a quadratic regression model for f of t with your calculator. Give 2 decimal places. So we put in our L1 and L2, and we do the quadratic regression model, which give us f of t is equal to 0.02 t squared minus 0.60 t plus 7.14. Now it says what's r squared? Get 3 decimal places. We know our r squared is 0.976. Now for D, explain how you could verify that the model found in B fits the data well. Okay, so we could do a quick little sample graph. So this would be 1.5, 2, 6, and 30. So we will have certain points here. And then we could basically draw a curve just about this here. So we would graph, and it'll be plot 1. And then we would zoom 9. And then the curve comes close to the points. Now, of course, we're typing in the y equals equation. So we would type this equation in y equals, and we will turn on our plot 1 and zoom 9. And this will be our final answer. Now we go here to E. It says find f of 25. So all we would do here is substitute in 25 for our t. So we would have 0.02 times 25 squared minus 0.6 times 25 plus 7.4, and that would give us 4.64. And we know that's interpolation. And then we will put in 2005. There were 4.64 thousand motorcycle deaths in the U.S. Now it says find t when f of t equals 8 by hand. What does it mean in terms of the situation? Verify your results by using intersect with the calculator. Include a sketch of the graph. Okay, Okay, so first of all, we need to get rid of the by hand. We could just put this in our calculator. And this is a sample sketch of the graph that you will have. And there were 8,000 motorcycle deaths in the U.S. in 1978 and 2011. So this right here will be your final answer after putting this in the calculator. Okay, now we'll go down here to G. Now it says, find the vertex of the model by hand. What does it mean in terms of the situation? Verify your results with the calculator. Include a sketch of the graph. Okay, what I did was take the liberty of putting all this information here first. So the first thing to find the vertex, we know we had negative b over 2a. Our b is a negative 0.6, and our a is 0.02. So we have the opposite of negative 0.6 and 2 times 0.02, which gives us 15. So f of 15 is equal to 2.64. That is our vertex. So in 1995, motorcycle deaths were at their lowest level of 2.64 thousand. And then also our x value would be 15. So x is 15. And also we will have 2.64 thousand deaths. And this you could get by pressing second, calculate, and then the number 3 for your minimum. Now we go to the next page, example 2. The following table shows the median age at which men and women first get married in the U.S. Let M of t and W t be functions for the median age at first marriage for men and women in the U.S. respectively at t years since 1900. So we know our L1 here would be 40, 50, 60, 70, 80, 90, 100, and then we will have 110. Now this is our L1 for the years, and then we know that men would be L2 and women would be L3. So we will put all this data in. It says, judging from the scattergrams of each data set, is it better to use linear, exponential, or quadratic functions to model these data sets? Okay, here if you notice, we go down, and then we go up. We go down, and then we go up. So we know that that is quadratic. And it's because the data goes down, then back up. Okay, now we need to scroll down here to B. It said find models for M of t and W t sent using regression. Give 4 decimal places. What is the R-squared value for each model? What does this indicate? So when you put these values in, of course we will be finding the quadratic models. So we will have 0.0018 t squared minus 0.206 t plus 29.0018. And then we will have y of 2, which is w of t, to give us 0.0019 t squared minus 0.2045 t plus 26.125. Now we go here to B. It says use the models to predict when the median age at first marriage will be the same for men and women by calculator. Using the graph and window given below, draw a sketch. Okay, so you make sure you set these values in your window. Now with this graph here, which I took the liberty of putting this in a little early, we have the women and men graph here using this window. And we notice that we have an intersection point of 162.28 for our t value or x value and 42.974 for our y value. It says in 2062, both 42 years old both will be 42 years old at their first marriage. So men and women will be about 42 years old at their first marriage. Okay, now we scroll to the next page. It says C, the optional problem. It says use the models to predict when the median age at first marriage will be for men and women by hand. Now this is optional, but I will show this problem to you. So what we would do is we would take the men and set it equal to the women. And we have our equations from previous steps, and we must get everything on one side. So what we decided to do here was move all of the men values over to the side of the women, and we would have 0 is equal to these values here. And then what we would do next is we would put this in a quadratic formula. You know, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we substitute in all of these values, and then we ended up with this value here, and we put this in our calculator after we take the square root of this value here. And so we would take the negative 0.0015 plus this value divided by 0.002, and then we would take negative 0.0015 minus 0.03396 all over 0.0002. And that would give us a negative, and it also would give us a positive. We know the negative would make no sense because that would take us back in time. So we have 162.3, and remember that is from the year 1900. So we would add this value to 1900, and it would give us approximately the year 2062. And this is how we prove it by hand, and we're done.